Hi class, this is Mr. Lucky. Kind of wanted to go over this first Intro to Stats lecture, video lecture with you guys, and kind of explain some important terms and definitions that we're going to be using throughout the course. So you might want to take a few notes as you watch the video, or I'm also going to post this PowerPoint that I'm going over at the bottom of the Schoology page so that you can open it up and you can make digital notes if you like and review it on your own time. So let's get started. Alright, so why study statistics? Data is everywhere. We use it every day without really knowing it. Statistical techniques are used to make many decisions that affect our lives, especially nowadays with the COVID-19 crisis. The case fatality rate, the number of people going into hospitals using ventilators, those are getting reported every day, and it's important information for us all to use. No matter what career you have, you're going to make professional decisions that involve data. So you're going to be looking at your pay scale, you're going to be looking at the number of years in education you need, a lot of things like that. Understanding these methods will help you make these decisions effectively. That's kind of why we study it. Also, it has a lot of applications to the business world. Maybe if you don't plan on being a science person once you get out of high school, if you're going to go into business, finance, marketing, management, you will see statistics every day in your job. Guaranteed. Alright, so what is statistics? You need to know this definition for sure. The definition is the science of collecting, organizing, presenting, analyzing, and interpreting data to assist in making more effective decisions. So the key words there are collecting, organizing, presenting, analyzing, and interpreting. We're going to be using those all year as well, and you're going to want to use those when you're planning and conducting your senior project. Statistical analysis is used to manipulate, summarize, and investigate data in order to draw valid conclusions. So again, this applies to your senior project when you do your experiment or your observational study, whatever it may be. You're going to want to show that you've done some sort of statistical analysis of your data to support your conclusions. Alright, so there's two main types of statistics that you need to know the difference between these two. Descriptive statistics is methods of organizing, summarizing, and presenting data in an informative way. So basically you're describing the data. Inferential statistics, the word infer in there, these methods are used to determine something about a population on the basis of a sample. So more often than not, when you're doing some sort of study or experiment, you're not able to get data from the entire population. So if you wanted to see what the average height of a Parkview student would be, it would be almost impossible to go measure every single student in the school. However, you could get a sample of students, measure those students, and then make some kind of conclusion based on that sample of the entire population. Speaking of those two words, population is the entire set of individuals, so that would be like all the students in Parkview. And the sample is a portion or part of the population of interest. So for instance, you could do all intro to engineering kids or all stat and technical writing students as your sample. Or you could do a random sample. Inferential statistics, again, it's drawing conclusions. So you could be estimating the population mean weight using the sample mean weight. You can test hypotheses. So we use inferential statistics to determine if there's a relationship between two variables. And what is the nature of that relationship? So like one question you could ask is there a relationship between mask wearing and new COVID-19 cases in the city? So you have two variables there, mask wearing and COVID-19 cases, And to see if there's a relationship between those two, we have to use inferential statistics, some sort of method to determine if there is a relationship. And we'll get more into that later in the semester. We're not going to go too deep into sampling in this one, in this lesson, but you do need to know that sampling methods can either be random or non-random. The goal is to have a random sampling method, which means each member of the population has an equal chance of being selected. That's not always possible, but you want to strive to get a random sample. The process of sampling also can cause sampling errors. So maybe the sample is not large enough, maybe it doesn't represent the entire population, and there's other factors involved there as well. We'll go into more detail in a later lesson. So back to descriptive statistics. So this is where we're going to collect data. Maybe we do a survey, maybe we're just in a park counting the number of birds we see. This is data collection. Maybe you're measuring the height of students. Then you're going to present that data in the form of a data table or a graph, and you can summarize that data by calculating the average, what is the minimum and maximum values. This is all considered descriptive statistics. Alright, statistical data. So the collection of data that are relevant to the problem being studied is commonly the most difficult, expensive, and time-consuming part of the entire research project. So I want you guys to start thinking about how you're going to collect data for your project. Whatever your idea is, always be thinking, what data am I going to collect? What am I going to measure? What am I going to count? Whether it's an observational study, like I said earlier, maybe it's an experiment, or even an engineering project where you're building some sort of device. You want to be able to collect some sort of data. So again, they're obtained by counting or measuring, and you have two types. You have primary data, which are collected specifically for the analysis desired, or secondary data. So this is stuff that's already been compiled and are available for statistical analysis. So maybe there's a database that has some measurements already on it. That would be secondary data. Someone else collected it, basically. Two other important terms. Variable is an item of interest that can take on many different numerical values. So the numerical value can vary, or a constant which has a fixed numerical value. Alright, so there's two categories of data you need to know also. So there's qualitative data. So this is data that falls into categories. They're not necessarily numbers. It's things like hair color, ethnic group, or some other attribute. That's qualitative data. The next one is quantitative. So this is data that are measured on a numerical scale. So this would be anything dealing with numbers. So when you see quantitative, think numbers. Qualitative, think categories. So qualitative data are not used as much, or if they are used, they're used with quantitative data, because you really can't get like an average hair color or average blood type. So you need some sort of quantitative data usually. And we're not going to worry about the two types of qualitative. Alright, quantitative data. So this results from counting or measuring, and you can separate quantitative data into two subgroups. You have discrete. So this is where discrete data is the result of counting, so like the number of students in a given ethnic group in class, the number of books on a shelf, etc. Continuous data is if it's the result of measuring, so like distance traveled, or weight or height, things you can measure. And here's a good chart to kind of show you how these terms are related. So variables, qualitative, quantitative. discrete and continuous. Alright, and I believe our last one here is different scales. So you have a nominal scale, which consists of categories in which each of the number the number of respective observations is recorded. So categories, these are in no logical order and have no particular relationship, so they're mutually exclusive. So this could be something like hair color or blood type, etc. Also, when you see nominal, think of name. You're using a name to label a series of values. Alright, next is going to be ordinal. So when you see the word ordinal, think order. So this contains a little bit more information. It has distinct categories, but there is an order implied. So think of like rating. When you do a survey, is it excellent, good, fair, poor? This would be an ordinal scale. Then you have the interval scale, which is a set of numerical measurements in which the distance between numbers is of a known constant size. So interval scales give us the order of the values plus the ability to quantify the difference between each one. And finally, the best one is the ratio. So it consists of numerical measurements where the distance between the numbers of a known constant size. In addition, there's no arbitrary 0 point. So what this means is it gives us the order, the interval values, plus the ability to calculate ratios since there's a true 0. And if that part's a little confusing, don't stress out too much about that. We'll have more practice with those terms later on. Alright, so that was the first Intro to Stats lecture. Now you're going to move on to one of your first assignment submissions. So if you'll look below this video on Schoology, you'll see a couple of questions I've typed out. And I want you guys to answer those questions in complete sentences, number your answers, and you'll just go over to the Submit Assignment button to the right and click it. In the window that pops up, you're going to click on Create, and you can just type your answers into the window there. So again, I would number each one, write in complete sentences where necessary, and let me know if you have any questions. Good luck.